I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will see the topic optical fibers, devices, that is dispersion and losses. So first we see about the main type of loss called dispersion. In communication system, dispersion is used to describe any process by which any electromagnetic signal propagating in a physical medium is degraded because of the various wave characteristics. For example, frequencies of the signal have different propagation velocities within the physical medium. What happens when the dispersion occurs in an electromagnetic wave is the dispersion causes that the optical pulses to broaden when they travel along a fiber. Because of the broadening of pulses, overlapping between the neighboring pulses takes place, which creates error in the receiver output. So this result the limitation of information carrying capacity of a fiber. And there are different types of distortion. The first case is intermodal dispersion, and the next broad category is intramodal or chromatic dispersion. So this intermodal dispersion, there are different modes propagated different group velocities. But intramodal or chromatic dispersion is further classified into three types. First case is material dispersion. This is due to the index of refraction of the medium changes with wavelength. And waveguide dispersion is due to the index change across the waveguide means that different wavelengths have different delays. And the third case, polarization mode dispersion, is the waveguide is birefringent and the birefringent is of the optical property of a material having a refractive index that depends on the polarization and propagation direction of light. And dispersion effect in optical fiber. So because of intermodal dispersion, what happens is the pulse, the modal dispersion is greatest in multimode step index fiber, and the multimode fiber different modes travel at different velocities. If a pulse is constituted from different modes, then intermodal dispersion occurs, and the modes, the greater the modal dispersion. The typical bandwidth of a step index fiber may be as low as 10 megahertz over 1 kilometer. So in the diagram we can see the multimode fiber. There are different modes are traveling, and because of different modes traveling at different velocities, there will be intermodal dispersion occurs. And another type is the waveguide dispersion. It is one of the classification of intramodal or chromatic dispersion. So this is due to dispersive nature of the bound medium. In a bound medium like the optical fiber, the velocity is the function of frequency. So the waveguide dispersion arises from a waveguide effects. The dispersion phase shifts for a wave in a waveguide differ from those which the wave would experience in a homogeneous medium. And the waveguide dispersion is more important in waveguides with small effective mode areas. But for fibers with large mode areas, waveguide dispersion is normally negligible, and the material dispersion is dominant in that case. And next is the polarization mode dispersion, and this is due to unequal velocities of two orthogonal states of polarization. So this mode of dispersion puts the ultimate restriction on the data rate on the long haul single mode optical fiber. The pulse slowly broadens due to the statistical fluctuation of the velocities of the two orthogonal polarizations. And optical fiber losses, if we take, there is another unit called attenuation, which limits the optical power which can reach the receiver, and it is the limiting span of a system. Once the power of an optical pulse is reduced to a point where the receiver is unable to detect the pulse, an error occurs. And attenuation is given by alpha is equal to 10 by L log 10 P out by P in. Here L is length of the fiber, and attenuation is measured by decibels per kilometer. And here Pin is the input power, the optical input power, and P0 is the output optical power. And absorption loss caused by the fiber itself by the impurities in the fiber such as water and metals. Scattering loss is intrinsic loss mechanism caused by interaction of photons with the glass itself. And third loss is the bending loss. This is due to the loss induced by the physical stress on the physical structure of the fiber. And optical fiber losses, material absorption loss is also another type of loss. And when when a material is eliminated, photons can make the valence electrons, often at term transition to higher energy level. When the photon is destroyed and the radiant energy is transformed into electric potential energy, and this will be re-emitted and called scattering. And there are two types of absorption, intrinsic absorption and extrinsic absorption. Intrinsic absorption is caused by interaction of one or more of the components of the glass, and extrinsic absorption is caused by impurities, external impurities within the glass. And bending loss, there are two bending loss, one is micro bend and the one is macro bend loss. So this micro bend loss is due to small discontinuities or imperfections in the fiber, and macro bending loss is observed when a fiber bends, radius of curvature is large when compared to the fiber diameter, and these bends are a great source of loss when the radius of curvature is less than several centimeters. And assessment time, intermodal dispersion occurs in a large amount in multimode step index fiber, results in pulse broadening at output. The modal noise can be reduced by using fiber large numerical aperture. Thank you.